Welcome back to Black Robot. Last time we studied theory, voltage, current resistors, and Ohm's law. So today we are moving from theory into practice. We will cover the three most important tools into the electronics: breadboard, power supply, and multimeter. So what is breadboard here? So breadboard basically we use to build circuits without soldering. So it means before soldering, if you want to play with your circuit, you can use breadboard. Power supply to why we use the power supply to provide safe and stable energy to the components, electronic components there. Multimeter, why we use multimeter? We use multimeter to debug the circuits, to measure the voltage, current, resistance, etc. So you can why hands-on tool matters. So if you many beginner projects fail not because of wrong code, but because of wrong wiring or unsafe power. Okay, so it's very crucial when you are working on embedded systems. You will have to keep in mind your all connections and the circuit and the power which it is moving through the resistor, capacitor, inductor, switch, LED, any kind of things that has to be measured one. Okay, so in embedded systems, breadboard, where you build the circuit, power supply, how you feed it, and multimeter, how you check if it is alive. So basically, in industry, hardware mistakes cost time and money. Knowing these tools makes you a real embedded engineer, not just a coder. So embedded engineer means here coding plus knowledge of electronics with electrical systems. So breadboard. What is breadboard? A breadboard is a solderless prototyping board. Okay, so inside metal strips connect rows of holes. You can insert resistors, LEDs, sensors, and jumper wire without permanent soldering. So in real life role, students use it to experiment. Engineers use it to test designs before making PCBs. Think of it like a whiteboard. You can try ideas, erase mistakes, and rewrite as much as you want. Okay, so this is how breadboard you're seeing. If you are seeing here the schematic diagram, here R1, R2, and R3. Three resistors are given there, and one power supply is given there. If you're seeing here, this is positive is red basically, red wire you will see, and for negative black wire you will see. Okay. So in that case, if you're seeing first resistor is connected and with this in vertical, second wire is connected with this resistor and this second resistor. Here, if you're seeing in vertical, this wire is connected in third resistor. So vice versa in second node as well, it is connecting here and it is going to the red wire. So this is the parallel series. Okay, I think you are aware about these things, how parallel series works here. So if you wanna test it, place an IC across the center gap on each pin and gets its own row. Okay, so let's build an LED circuit here. In, insert resistor, okay, in here, okay. Insert resistor into the horizontal direction and vertical direction if you are seeing how it is connected there. Ground is connected this one and this ground is switch one is connected here and one ground is going here and this is connected here. Okay, if you are giving the voltage here, so this is the uh, long leg, the long leg is connected the voltage. So this will connect with the this LED. Again, this 5 volt is going here. If you are seeing here, this connection, okay, going here to this one into the vertical direction. If you are seeing, okay, this vertical direction is having the same connection. My bad. This is not a vertical. This is horizontal. Keep in mind, this is horizontal one. Okay, if you are going here, horizontal is connected with this one, this long leg, and if you are seeing this the vertical one, vertical this one small leg is connected with this resistor and this one this here, and again this switch is connected with this wire, and this wire is connected in horizontal with this ground one. So if you are seeing here horizontal into the large two corners, horizontal is having same voltage. If you are connected with the voltage, voltage would be there. If you are connected with the ground, ground would be there. And in between one, this vertical would be having the same. Okay. So this is how it works. So, so in that case, these LEDs will glow. Okay. So this you can prototype on your breadboard. This is easy to use it. Beginners often misfire circuits. So first one, putting both register legs in the same row, so it can cause to the short circuit. Okay, so these are the common mistakes you can do it. Okay, so these things also I have done it. So while doing, I I learned these things. So forgetting. So second point can be the forgetting to connect ground rail. Third point can be the loose jumper wire causing flickering release. Okay, so these are the common mistakes are there. So while debugging, it reveals wiring issues. Okay, so these errors look simple, but they waste hours of debugging. So you will not be getting where exact the issue is there. So I will give a tip here. Always check wiring with a multimeter before powering the circuit. Okay, so we will cover multimeter later in this chapter. So why power supply matters? Every circuit needs power, but not every circuit accepts the same voltage. Arduino, accept 5 volt, ESP32 accept 3.3, but some sensors, accept can be the dual supply. It can work onto the 5 volt as well as the 3.3 volt logic. So if you connect the wrong voltage, components can burn instantly. That's why knowing your supply is as important as knowing your code. So battery power. Batteries are portable and simple. So if you are using ASL, so this can be 1.5 volt. 4 cells battery would be the 6 volt in a series. So 9 volt battery handy but weak for motors. Ion battery is 3.7 volt nominal but 4.2 volt when fully charged. So ESP32 runs on a 32 volt. If you connect a on battery directly at 4.2, it may damage the chip. That's why regulators are needed there. Okay. So you can't directly connect with the higher voltage, those circuits. Those are very sensitive. So USB power gives regulated 5 volt, perfect for development boards. Arduino is connected with the USB. So that's a onboard regulator. So which, having the 3.3 pin there, 3.3 volt pin. ESP32 goes with the USB 5 volt it regulator it is having, so it is safe for the 3.3 volt operations. Never connect 9 volt directly to the 5 volt pin. So battery power supply in labs we use bench power supplies. They let you set exact voltage and limit current. So if you're seeing here output, input, voltage, current, everything you will be seeing. So three kind of things you will be getting: one ground voltage, one and third one would be the common there as well. So in that case, you can set 5 volt current limit 200 milliampere. If your circuit tries to draw 500 milliampere, so supply shuts down. This feature is life-saving in both classroom and industry. Power regulation. What is power regulation? It is to ensure stability there. Basically, regulators are used, okay, 7805. So that converts 12 volt to 5 volt. LDO is there. That is efficient at lower drops. So buck converters are there. So high efficiency step down used in basically IoT. So I will give an example there. A solar powered IoT node uses a buck converter to step 12-volt solar panel down to 3.3-volt microcontroller supply. So it's without regulation, voltage fluctuation would reset or destroy the MCU. So this is what multimeter is this. Okay, if you're seeing here, okay. So basically a multimeter is the Swiss Army knife of electronics. It measures voltage, current, resistor, continuity, everything. So before powering any circuit, engineers check it with the multimeter. In industry, this is mandatory. If you're seeing here, okay, so here you can off it AC, DC, millivolt. Okay, so you can check the continuity current here as well. So you can connect with the voltage and communication port here. Okay, so this is how you can use the wire with that. So measuring the voltage, how you can measure it? So you can, set with the DC one and set meter to DC volt. So you can read the red one, you can connect with the VCC, and black probe you can connect with the ground. So suppose Arduino 5 volt pin should read 5 volt. If 4.3 volt, so that's a weak USB port. If 7 volt, regulator fault board in danger. So these kind of situation you can handle it there before checking before connecting any kind of voltage power to the uh, microcontroller. So how you are measuring current? Current must be measured in series. So for example, LED plus resistor is expected to 20 milliampere. If resistor is too small, okay, so current would be 100 milliampere or greater than equal to. So LED life shortens. So start on high here range. Many beginners blow the multimeter fuse by connecting wrong. So measuring resistance comes into the picture to measure resistance. So this turn off the circuit plays both across registers. Okay, so you will have to turn off the circuit to check the resistance there. So the probe you will connect the same, and you will have to just round it in the circuit to measure the resistor here. Okay, in this picture if you're seeing. Okay, so we are showing two 20-volt resistors, so 218 volt. That's a tolerance. Because of that, you can go plus minus 5% or plus minus 10% according to the uh, component specification. So measurement you can use into the live circuit, okay, and also into the live circuit. You can get the wrong values as well. So these kind of you will have to again and again check it how much voltage reached you are getting there and current as well. Okay, so how you are checking? So we have discussed just now measuring how you are measuring resistance there, and third point continuity test. So in that case, you will have to probe, you know, set the at the continuity. So in continuity, check if 2 points are connected. So in that case, multiple will beep it if path is completely there. So in a wire, if there is no cut it, if that is not wire is not faulted or it is not got damaged, so you will get a beep there. So for example, if button not working, test continuity. Okay, so if pressing closes circuit button is fine. So engineers test PCB tracks with this way before applying power. So here you are seeing, right, how I will give you the practical example in that case. Okay, so LED onto the circuit breadboard you have given there. So build a little resistance circuit there, supply 5 volt. You can give it 5 volt, okay, and resistor is there, and LED drop to 2 volts. So resistor drop would be 3 volt there. So 5 minus 2 would come into the picture, right? So here if you're seeing, right, so the drop would be 5 minus 3 is equal to 2. Okay. So that's you can confirm via Ohm's law as well. So we have discussed in previous lecture. If you are not aware of the basic electronics, you can go my previous lecture. So I have discussed about the Ohm's law there. So how you can power on microcontroller safely. So basically, in case of ESP32, suppose I'm giving an example there. So USB supplies 5 volts. So there is a regulator. So you can supply to the 3.3 volt this microcontroller. You connect 5 volt directly to 3.3 volt and you will burn it. So in data sheets and pinouts always show safe powering methods. So you will have to always see the pin diagrams and also the data sheets of the controllers before going to implementation there. So how you can debug with the multimeter. So when LED doesn't glow, check if 5 volt present. Okay. So these are the basic steps you will have to follow it if LED is not glowing. So for example, okay. So when LED doesn't glow, first point, check if 5 volt present. Second point, check register value. Third point, check continuity from MCU pin to LED. So 9 out of 10 beginner issues are wiring mistakes, not bad components. Always keep in mind about that. Okay. So battery check is given there. For IoT projects, batteries matters. So Lion battery is 4.2 volt. You will get a full one, and 3.7 volt is a nominal one, and less than 3 volt is the unsafe one. So without monitoring, batteries over discharge and lose capacity. Okay, so multimeters prevent this and extend battery life. So you can use the multimeter there to check the battery voltage. So let's wrap it. Okay, so what are the key takeaways from this lecture? Breadboard basically you can use for prototyping. Okay, and power supply is a safe operation, and you will have to always keep in mind for particular controller you will have to give the particular power supply. Otherwise, microcontroller will get burned. Okay, so you can use multimeter for that. And before going for implementation of circuit directly soldering there, so you can work onto the breadboard. Okay, and also you can use the regulators to stabilize the voltage if any fluctuation is there. Okay, so multimeter you can use for diagnosis the things of the circuit. So this all together you can combine with the embedded engineers to fit. Okay. So now you have learned embedded C, now basic of electronics. Now further we will learn more about that. Okay. So let's wrap it. Thanks. Thanks everyone.